नॉर्मल, एक मिनट। हेलो।
जी मैम।
Okay, so earlier we have done test for significance, and in that, based on normal distribution, है ना, we find the z statistic there, है ना? Do you remember that? हेलो।
यस मैम।
एक मिनट, मैं सबको ज्वाइन एक बार ले लेती हूँ। Okay, so now we
यस
will
मैम।
do the same test statistics in terms of chi-square distribution. All right, now our statistic will be based on chi-square distribution. All right. Okay. Suppose we want to test if a random sample xi, ये भी मैंने सेंड नहीं करा है, ठीक है, बिकॉज ये रफ में लिखा हुआ था, एंड बिकॉज एज आई वॉज बिजी आई वॉज नॉट एबल टू राइट इट प्रॉपरली, सो इसलिए अभी ये मैंने सेंड नहीं करा है ग्रुप पे, ये सिर्फ पढ़ाने के लिए ही है। आई विल गिव यू व्हेन आई, मतलब आई राइट बाय माई सेल्फ। अच्छा ये बताओ, कुछ ऐसा अभी तक तो नहीं है जो मैंने छूट गया और मैं नहीं दे पाई हूँ? हेलो। हेलो, एम आई ऑडिबल?
यस मैम।
कुछ अभी ऐसा तो नहीं है जो छूट गया और मैं नहीं दे पाई हूँ? तो प्लीज़ मुझे दिला देना, ठीक है? वैसे तो मैं सब दे देती हूँ, लेकिन हो सकता है कभी भूल गई हूँ। सपोज वी वांट टू टेस्ट इफ अ रैंडम सैंपल xi has been drawn from a normal population, all right, and we have the null hypothesis that sigma square is equals to sigma naught square. All right, so we have some sigma square and we have to compare it with the given sigma square, sigma naught square, कि whether it is equal to that or not. So under the null hypothesis the statistic, देखो z statistic जो थी, that was variable minus expected value of variable divided by
वेरिएंस।
standard deviation. Now इसमें क्या है? It will be written as summation xi minus x bar square, मतलब whole square, divided by sigma naught square. All right, this will be our chi-square statistic. देखो, the test will remain the same, है तो test of significancy, बस now what we are doing is that we are changing the test statistic. All right. Hello.
यस मैम।
Okay, so what we can do is that we can take 1 upon sigma naught square common, and we will get it as summation xi square minus nx bar square. ये वाला relationship, do you know how to solve this relationship? ये summation xi minus x bar square को हम ऐसे लिख सकते हैं, do you know how we will get this? Summation xi square minus nx
यस
bar
मैम।
square,
यस मैम,
कैसे
स्क्वायर रूट खोल देंगे तो इतना ही कर दिया।
हाँ, स्क्वायर रूट खोल देंगे, फिर भी अगर दिक्कत है तो आई कैन एक्सप्लेन यू सो दैट जिनको सबको समझ में आता है, या फिर एक्सप्लेन करूं? एवरीबडी नो दिस
यस मैम।
कि हाउ वी हैव गॉट समेशन xi minus x bar square as this term. We will open the square and we will get xi square plus x bar square minus twice of xi into x bar. फिर when we will take the summation, एक बार मैं बता देती हूँ, या फिर बताओ, एवरीबडी नोज दिस और नॉट? अगर किसी को नहीं आता, प्लीज इट इज बेटर दैट यू आस्क मी, otherwise I will proceed further. हेलो। एवरीबडी नो ना कि हाउ यू विल गेट दिस? हेलो। हेलो भाई, प्लीज
यस
बताओ,
मैम।
यस मैम।
सबको पता है? किसी
यस
को
मैम।
ऐसा तो नहीं किसी को नहीं पता? ओके, so we will get this, and we know that this is n square, है ना, because summation I is equals to 1 to n xi minus x bar whole square upon n is equals to small s square, है ना. So we can say that this term is what? ns square. All right. Hello. Have you got how you have got ns square in place of this summation x square I square minus nx bar square? Hello. Hello. Am I audible? Okay. Now, because we know that s square is equals to 1 upon n summation xi square minus x bar square. So, in place of this summation xi square minus nx bar square, we have written the product of n into s square, because this will be equal to this summation xi square minus nx bar square. Is it clear? Now, this is our test statistic ns square upon sigma naught square. This is following chi-square distribution with how many degrees of freedom? N minus 1 degree of freedom. Alright, you can understand it by this. See, we have n variables here. x1, xi squares are involving n variables. Because it is summation xi square, na? So it is involving n variables. x1 square, x2 square. So we have n variables here, and x bar square is a single variable. So this will follow chi-square distribution with n minus 1 degrees of freedom. You can understand that by this, means why it is following n minus 1 degrees of freedom. All right. Hello.
Yes, ma'am.
Okay. Now, at last we will compare. So, can anyone tell me what are the steps of when we do test of significance? What are the steps which we proceed? सबसे पहले क्या करते हैं when we are doing test of significance? किसी भी चीज के लिए टेस्ट ऑफ सिग्निफिकेंस फॉर मीन वेरिएंस, किसी भी चीज के लिए बताओ कैसे करते हैं? हेलो.
मैम हम वो जो वैल्यू कैलकुलेट की है,
नहीं, स्टार्टिंग से बताओ. सबसे पहले क्या करते हैं? सबसे पहले नल और अल्टरनेटिव हाइपोथेसिस डिफाइन करते हैं.
नल हाइपोथेसिस और अल्टरनेटिव हाइपोथेसिस
डिफाइन करते हैं. ठीक है. उसके बाद हम टेस्ट स्टैटिस्टिक डिफाइन करते हैं. ठीक है ना. टेस्ट स्टैटिस्टिक किस चीज के ऊपर बेस्ड होती है कि भाई हम मीन निकाल रहे हैं, मतलब मीन है हमारा, टेस्ट ऑफ सिग्निफिकेंस फॉर सिंगल मीन कर रहे हैं, वेरिएंस कर रहे हैं, जो भी होता है उसके अकॉर्डिंग हम लोग टेस्ट स्टैटिस्टिक निकालते हैं. ठीक है. टेस्ट स्टैटिस्टिक कैसे निकालते हैं? क्या फॉर्मूला होता है टेस्ट स्टैटिस्टिक का निकालने का? वेरिएबल इन्वॉल्व माइनस
Mean of the standard deviation.
माइनस एक्सपेक्टेड वैल्यू ऑफ द मीन और एनीथिंग, जो भी वेरिएबल है,
upon under root of
standard
variance.
deviation of, yes, that is our z statistic. Now what we
Yes,
do,
ma'am.
we have got the test statistic, we have got the
मैम क्रिटिकल पॉइंट देखते हैं.
critical points देखते हैं. कैसे? How the critical point is,
मैम कुछ भी हाइपोथेसिस लेते हैं ना, एच नॉट जो भी लिया है हमने, एच नॉट लिया है जो भी, या एच ए ऑल्टरनेटिव जो भी लिया उसके बेसिस पे.
alternative hypothesis, it will be based on alternative hypothesis, not on h naught. H naught is your null hypothesis.
Yes,
H A or H1 is your alternative hypothesis.
करेंगे.
If we will see that if our alternative hypothesis is right-tailed, left-tailed or two-tailed, depending on that, we will find the tabulated value of z at that particular level of significance, that at 5% level of significance or at 10% level of significance, we will find the value of z, and the value which we have obtained from the z statistic, we will compare this value, that is the value which we have got is our z, the value which we have got is our z calculated, and the value which we will obtain from the table depending on whether our test is left tailed, right tailed or two tailed, and depending on the level of significance which we are choosing,
Significance.
we will
Yes, ma'am.
get this z tab or z tab, anything you can say. Now we will compare this z calculated with our z tabulated. Now what we will do,
हम कैलकुलेट करने के बाद अगर क्रिटिकल रीजन में आ रहा है, रिजेक्शन रीजन में आ रहा है या एक्सेप्टेंस रीजन में आ रहा है,
अगर most of the time it happens कि अगर z most of the time क्या it happens, if z calculated is less than z tabulated, it means the hypothesis will be
मैम Z
hypothesis will be
कैलकुलेटेड
is less than z
Rejected.
tabulated, the hypothesis will be
Accepted.
मैम एक्सेप्टेड,
Accepted.
it will be accepted, because see, this is our region, this is our z tab, and this is the area of rejection. Now our z calculated is coming in this region, है ना, because it is less than z tab, means less than z tab,
Yes,
it
ma'am.
will lie on the left hand side, so it will lie in the acceptance region, therefore our hypothesis will be accepted. All right.
Yes, ma'am.
Okay. So similar, the procedure which we have followed there, we will proceed. We will follow the same procedure here also. Now we have got the
If battery is less than 20%, please turn off on your battery saver.
हाँ, वो मेरी बैटरी खत्म हो रही है, शायद इसी वजह से जो है प्रॉब्लम हो रही है. मिनट. Okay, so what we will do now? We have got the chi-square statistic. Now what we will do? Hello?
मैम Z इसका फाइंड करेंगे, Z स्टैटिस्टिक्स.
Z स्टैटिस्टिक में नहीं फाइंड करेंगे, हमें chi-square स्टैटिस्टिक तो मिल ही गई है ना, है ना.
यस मैम.
यहाँ पे हम z टेस्ट थोड़ी लगा रहे हैं, यहाँ पे तो हम chi-square टेस्ट यूज कर रहे हैं ना, तो z स्टैटिस्टिक का तो अभी कोई जिक्र ही नहीं आएगा. देखो chi-square हम कब यूज करते हैं, जब हमारा सैंपल साइज लेस देन 30 होता है. जब हमारा सैंपल साइज, इफ आवर सैंपल साइज इज ग्रेटर देन 30, we will directly use z statistic. But if our sample size is less than 30, then what we will do? For such cases, we use chi-square test. All right. Have you understood the difference between why we are using chi-square test here? We could use z also, z statistic also, z test also, but why we are using chi-square test? Because our sample size is less than 30.
Less than 30.
All right. Yes, for less than 30, we only use chi-square test only for those cases where our sample size is less than 30. अब हमेशा तो तुम्हें हाई सैंपल साइज नहीं मिलेगा ना कि हमेशा तुम्हें n = 100 मिल जाएगा. It will not happen, मतलब every time you will not get n greater than 30. So for the cases where n is less than 30, we use chi-square test. Is it clear?
Yes ma'am.
yes ma'am.
Okay. Okay. So now यार एक बार में ज्वाइन क्यों नहीं करते हो? Okay. So now what we have got our test statistic in terms of chi-square. This is our test statistic, that is n square upon sigma naught square. So what we will do, we will compare it with, this is our chi-square calculated. All right, we will compare it with tabulated value of chi square, and if it is less then the test, if it is less than the calculated value, वो tabulated value, then our hypothesis will be accepted, otherwise it will be rejected. Everything will remain the same except the statistic, test statistic. All right?
Yes, ma'am.
Okay. At last we will compare the tabulated value with calculated value with the tabulated value of chi square for n minus 1 degree of freedom, and at certain level of significance. It can be 1%, it can be 99% level of significance, anything. All right. Then if the calculated value is less than the tabulated value, the hypothesis will be accepted, otherwise it will be rejected. All right. The above test can be applied only if the population from which the sample is drawn is normal. So this test can be applied only if the sample which is taken is normal. All right. If the sample size is large, that is, it is greater than 30, then Fisher's approximation can be used. All right. If the sample size is greater than 30, then what we can do? We can apply Fisher's approximation. And वो क्या होता है? Fisher approximation ये होता है that under root 2 chi square will follow normal distribution with mean under root 2n minus 1 and variance 1. So what we can do is that we can subtract this mean value from this, and we will see that then our under root 2 chi square minus under root 2n minus 1 will follow normal distribution with variance 1 and mean 0. All right. I think if you will solve some numerical, it will be more clear. It is believed that this is a numerical. Hello?
Yes, ma'am.
Hello?
Yes, ma'am.
Okay, it is believed that the precision as measured by the variance of an instrument is no more than 0.16. Write down the null and alternative hypothesis for testing this belief, carrying out the test at 1% level given 11 measurement of the same subject. मान लो we have some subject, समझ लो it can be your erasers, ठीक है, और erasers की size are 2.5 centimeter, 2.3 centimeter, 2.4 centimeter. So we have 11 different erasers. All right. Hello. Hello.
Yes, ma'am.
Yes, ma'am.
So what we have to find is that the variance, that is the standard deviation, that is the difference between the all the these variables measurements, it should not be more than 0.16. That is, we have sigma square, that is we have sigma square is equals
मैम आप
to,
स्क्रीन को टिल्ट कर लीजिए.
मैं स्क्रीन को टिल्ट नहीं कर पा रही हूँ क्योंकि ना मैंने कहीं सेंड नहीं कर रखा है ना, तो वो पीडीएफ में खुल नहीं पा रहा है.
ओके मैम. ओके.
ये कैम स्कैनर के थ्रू ही खुल पा रहा है, इस वजह से मुझे प्रॉब्लम हो
ओके
रही है.
मैम.
एक मिनट, स्क्रीन शेयर हो रही है क्या? हेलो.
यस मैम हो रही है. मैम हो रही है.
ओके ओके, एक मिनट रुको.
भाई स्क्रीन को रोटेट कर लो, हो जाएगा सही.
भाई हमने तो
नहीं,
कर
स्क्रीन
रखी है
रोटेशन
मैम
से
की.
क्या, नहीं मैं भी एक मिनट रुक जाओ, मैं भी करती हूँ. ठीक है. ऑल राइट.
ओके मैम
Hello?
अब हो गया.
Yes, ma'am.
So
Yes,
it
sir.
is believed that Okay, it is believed that the precision as measured by the variance of an instrument is no more than 0.16. That is the variance which is given to us. We are saying that the given value of variance is 0.16. तो इसका मतलब is क्या हो गया? That the null hypothesis is sigma square is equals to
0.6
0.16.
0.16 sorry.
है ना? And what will be the alternative hypothesis? That it is greater than,
Greater than 0.16.
ठीक है, it is no more than 0.16. All right. So what we will do, this is our 2.5. These are our values of x, different values of x. That is mean. All right. So we can find x bar also. 2.5 plus 2.3 minus 2.4,
हो जाएगा
2.3,
मैम.
etc. All right. Now you can also find x minus x bar.
Yes ma'am.
All right. You can also find summation xi minus x bar square या summation x minus x bar square.
Okay ma'am.
So we will get this value of 0.1891 as summation x minus x bar square. Now this is our alternative hypothesis. Sigma square is is greater than 0.16. Now we know the test statistic will be ns square upon sigma square, and ns square can be replaced by summation x minus x bar square. We have already done this. We can replace this ns square by summation xi minus x bar square. है ना? Just look at the screen. As s square. Hello? Hello?
Yes, ma'am.
Hello? As s square is equals to 1 upon n summation xi square minus x bar square. So ns square will be summation xi minus x bar square. हेलो भाई कहाँ चले गए? नहीं समझ में आ रहा है क्या? So we can write this in place of this. Our test statistic is what? Our test statistics is this n square upon sigma naught square. We have got the value of this summation xi minus x bar square. So we can replace this n square by summation xi minus x bar square or not?
Yes, ma'am.
Okay. So now our test statistic will become summation xi minus x bar square upon
Sigma square.
sigma square, sigma naught square. And what is the value of sigma naught square? What is the given value of variance with which we have to compare?
0.16, ma'am.
0.16. So our test statistic will become n square upon sigma naught square. It is sigma naught square. All right. Summation xi minus x bar square upon sigma naught square. This is equals to 0.1891 upon 0.16. And the value is coming out to be 1.182. Now we will see the chi-square table. For how many degrees of freedom? We have 11 observation. All right, we have 11 observation. So how many degrees of freedom
Yes, ma'am.
will be there with which we have to compare?
10.
We have done this now. 10 because this test statistic chi-square will follow chi-square distribution with n minus 1 degrees of freedom. As the number of items involved are 11, so it will follow 11 minus 1, that is 10 degrees of freedom. All right. So this is our table of chi-square distribution. Now, 1 minute. Okay. Now for 10 degrees of freedom, at 1% level of significance, the value is Hello?
Yes, ma'am.
Hello? See, this is the value, the rightmost value is giving us 1% level of significance. Next value towards
23.21.
yes, 23.21. Now moving towards left, the next value is giving us 5% level of significance. The next value 10%, then 25%, then 50% level of significance. So it is giving us different values of alpha, but as we have to find at different degrees of freedom also, because हमें क्वेश्चन में ये गिवन हर क्वेश्चन हमारे पास डिफरेंट होगा कि कभी हमारे पास केस में n is equals to 5 हुआ, मान लो कभी n is equals to 6 हुआ, तो फॉर डिफरेंट डिग्रीज ऑफ फ्रीडम द वैल्यूज ऑफ दिस and for different values of alpha we have different values of this chi-square. All right, so now for 1% level of significance and at 10 degrees of freedom our value is 23.21. All right, see, this table is for on the right side you can see, see on the right side, left side you can see there are degrees of freedom. मेरा पेन नहीं चल पा रहा इस वजह से I cannot write.
मैम दिख रहा है मैम.
This is नहीं दिख रहा?
मैम दिख रहा है मैम.
Okay, so these are the degrees of freedom and these are the values of alpha, that for 99% of level of significance, and for 1 degree of freedom we will have 0. For 95% level of significance and for 1 degree of freedom we have value 0.004. Then for 90% level of significance and 1 degree of freedom we have value
0.16.
0.016. So like this,
Yes, ma'am.
yeah, 0.016. So like this we can get different values. Now this is the value for 10 degrees of freedom and at 1% level of significance, 23.21. So we will compare our we will compare our test statistic with which value? Tabulated value is now
Chi-square tabulated.
23.21. This
Yes,
is
ma'am.
our chi-square tabulated 23.21. So we will calculate. So we will compare our chi-square calculated with chi-square tabulated, and if it is less than that, then our hypothesis will be
Accepted.
He accepted.
accepted. जब छोटी होती है तो accept होती है, जब बड़ी
Yes,
होती
ma'am.
है तो reject होती है. So as our chi-square calculated is how much?
1.182.
1.182, which is less than 1.182 is less than 23.
20.21.
23.21. So our hypothesis will be
Accepted.
accepted. Okay, next question. Is it clear? समझ में आ गया ये chi-square
Yes,
का
ma'am.
concept? Okay. A firm manufacturing rivets. Rivets क्या होते हैं? हेलो
मैम पता नहीं.
हेलो रिवेट्स वो होते हैं जैसे
Sir,
नेल्स
nuts.
होते हैं ना, नट्स टाइप के, हाँ, पेज जो होते हैं,
अच्छा.
ठीक है. A firm अब्दुल अहद, अब क्लास ज्वाइन करके क्या फायदा? अब तो 10 मिनट रह गए हैं मुश्किल से क्लास खत्म होने के.
सॉरी मैम, देर से मैसेज देखा था.
अच्छा सर, a firm manufacturing rivets want to limit variation in their length. All right, कोई कंपनी, a certain company is there which is manufacturing rivets and it is want to limit variations. Limit variations means it is want to reduce variations. All right, कि जितने भी हम, मान लो कोई कंपनी रिवेट प्रोड्यूस कर रही है, मैन्युफैक्चर कर रही है, एंड उसमें बहुत वेरिएशंस हैं कि कोई तो थोड़ी बड़ी है, कोई छोटी है, तो उस वेरिएशंस को रिड्यूस करने के लिए, ठीक है, they want to perform a test. All right, is it clear?
Okay, ma'am.
Yes, ma'am.
The length in centimeter of 10 rivets manufactured by a new process. So what they are doing, they are applying a new process. Earlier the process was there, it was giving lot of variation. Now they have changed, they have switched over to a new process, and now they wanted to know that whether the new process is better than the old process or not. All right,
Okay, ma'am.
and how can we do this, that whether the variations are reduced or not?
मैम काई स्क्वायर डिस्ट्रीब्यूशन से पता कर लेंगे.
जी, अच्छा, why we are using chi-square statistic here? Can
N
anyone
N
tell
is
me
equal to 10.
exactly?
equal to
Very
10.
good.
10 है ना.
Because n is equals to 10 है. Yes. In the past, the variation, the length of rivets manufactured by the firm has been 0.021 centimeter. Now, do you know what is variation? Variation means
Standard deviation.
variance.
Variance.
All right. Means earlier the variation was found to be 0.021. Now we wanted to know whether the variation has reduced or not. All right. So our null hypothesis will be that the variation has not reduced. All right. That is sigma square will be equals to 0.021. That is the earlier process. The earlier process was giving the variation of 0.021, and now the new process is also giving us the same variation, that is 0.021. So for considering this, we have made our null hypothesis as sigma square is equals to 0.021. Is it clear?
Yes, ma'am.
And alternative hypothesis will be sigma square is less than 0.021. That is our new, that is it has improved. All right.
Yes,
now we know the test statistic will be summation. This is our test statistic. We know the
xi
formula for chi.
minus.
This is our chi-square test statistic.
Yes, ma'am.
All right. Now you can find summation xi minus x bar square.
Yes,
Can you
ma'am.
find it? How will you find?
मैम सबका सम करके जितने हैं उससे डिवाइड कर देंगे.
By 10.
Yes, that will be our mean, है ना?
Yes, ma'am.
और जैसे मीन मान लो, जरा निकाल के बताना मीन कितना आ रहा है. मेरे पास तो कैलकुलेटर नहीं है अभी. एक मिनट.
अरे मैम कैलकुलेट करेंगे.
हाँ, 2.15 plus 1.99. क्या आ रहा है? मीन
मैम एक मिनट.
2.068. So how will you find this summation xi minus x bar square? 2.0. What was the value? 2.068. Okay. So you can find, how will you find summation xi minus x bar square? 2.15 minus 2.068, then 1.99 minus 2.068, and इन सबका स्क्वायर ऐड हो जाएगा. All right. So when we will add all the terms, what we will get? We will get this summation xi minus x bar square. Is it clear?
Ji,
Is
ma'am.
it clear how we will get
Yes,
this
ma'am.
summation xi minus x bar square? And then your sigma naught square is given, that is 0.021. So we will put these values over here, and we will get the value of chi-square statistic as 4.326. 326. Now
मैम
we
इसके
have
अंदर गिवन नहीं है तो फिर हम इसे 99% पे ही चेक करेंगे।
99% पे भी चेक कर सकते हो, 95% पे भी चेक कर सकते हो, मतलब ऐसे तुम अगर एक पे भी चेक कर लोगे तो इट विल बी सफिशिएंट। ठीक है, वैसे
Okay, ma'am.
क्वेश्चन में ना अगर एग्जाम में आता है तो इट विल बी गिवन दैट यू हैव टू चेक इट फॉर 99% लेवल ऑफ सिग्निफिकेंस और फॉर 95% लेवल ऑफ सिग्निफिकेंस। ऑलराइट,
Okay, ma'am. Okay.
now they have checked it for both 99%. What will be that value of degrees of freedom?
9.
9. So we have to check it for 9 degrees of freedom at 95%,
3.325.
at 95, 3.325 and 2.088. All right, and what is the value which we are getting?
4.326.
4.326. Okay, so it is greater than 2 points, so the R
Rejected.
New process is better.
हाँ, न्यू प्रोसेस विल बी बेटर। इसमें उल्टा क्यों लिखा हुआ है दैट द न्यू प्रोसेस इज नॉट सिग्निफिकेंटली सुपीरियर?
मैम ये हमारा रिजेक्शन पार्ट में चला जाएगा ना?
अरे 4.326 is greater than 2.088, so it will be rejected, it will not be accepted,
यही मैम रिजेक्टेड ही तो कर देंगे इसे।
it will be rejected, it will not be accepted। इसमें गलत लिखा हुआ है, ठीक है?
ओके मैम।
ओके,
हम इसमें उस
So-
तरीके से भी मान सकते हैं कि 3 से ज्यादा होगा तो रिजेक्ट ही करेंगे हमेशा।
वो नॉर्मल डिस्ट्रीब्यूशन के लिए होता है 3 से ज्यादा, इसके लिए नहीं होता
इसमें नहीं
वो।
कर सकते?
नहीं नहीं नहीं, इसमें नहीं कर सकते वो।
ठीक है मैम।
ठीक है, उसका भी तुम एक न्यूमेरिकल देखो तो तुम्हें समझ में आ जाएगा। देखो वो हमने कब करा है, उसको नॉर्मल डिस्ट्रीब्यूशन के इक्वल कब करा है? अगर हमारा सैंपल साइज इज ग्रेटर देन 30, देन वी कैन, देखो इट वाज रिमार्क, it was the remark written, if the sample size n is greater than 30, then Fisher's approximation can be used. That is, z is equals to under root twice of 5 square minus under root twice of n minus 1 will follow normal distribution with mean 0 and variance 1. But it is when n is greater than 30. Then only we can compare it with, if our n is greater than 30,
Z.
then we can get z. And then we can compare it with greater than 3, कि अगर 3 से बड़ा होगा then it will be rejected। तब हमारी z statistic आ जाएगी ना, और z statistic की कंडीशन होती है that if the calculated value is greater than 3, then our hypothesis will be rejected। all right, so अब ये क्वेश्चन देखो तो तुम्हारी डाउट शायद क्लियर हो जाए। सी, sigma square is equals to 100 given, all right, and s square is equals to 1 upon n minus 1 summation xi minus x bar, that is capital S square is given to you। all right, now what we have to do is that we will find the chi-square, and the value of chi-square will be this 2 into 49 into 225 upon 100, and as n was 100, n was 50, so twice of n will be 100, and this will be 2n minus 1, that is 99. Now we are getting this z is equals to 5.05, which is greater than 3. Now we have got the z statistic, and we can say that the hypothesis will be rejected।
Yes, ma'am.
ठीक है, this is chi-square, it will be compared with your chi-square table only, and this is, if you have to change it in terms of z statistic, then the condition is that the sample size should be greater than 30, then only we can approximate it to standard z statistic। all right,
ओके मैम।
Yes, ma'am.
okay, so that's all for today। I will repeat these last two topics, last two numerical once again। all right,
यस मैम।
so you can leave, wait, अटेंडेंस अपनी दे देना मुझे ग्रुप पे। ओके।